Last problem. When a man stands at a certain distance from a building, the angle of elevation to the top of the building is 21.8. When he walks away in the same direction, the new angle of elevation is 11.3. So I'm going to draw a building. And then a man. And his angle of elevation, so eyesight. Okay, so sometimes it matters what his eye level sight is, and sometimes it doesn't. If they tell you how tall his eyes are off the ground, it matters. So make sure to draw that in. So I drew this person in because it told me that the man's eye level, which is 1.8 meters above the ground. So when I draw in my horizontal line, I know that this height right here is 1.8. And his angle of elevation for the first time is 21.8. And then it says that he walks 5 meters away, 50 meters away, and at 11:50, this is why, because I keep forgetting the numbers. Okay, so then he walks 50 meters away and has a second angle of elevation of 11.3. So drawing in that eyesight with the horizontal. That is 11.3. I am looking at all of this information that's been given to me. I need to find the height of the building, and I'm moving from the information that I do have into information that I want to find. I have information about a lot of stuff. I don't have any information or full side lengths at all of any of the triangles. I do, however, if you're going to try and shift your focus on that furthest right triangle, with the one that's formed with the green and the 11.3, I have the full side length of 50 there, and then I have an angle. So that seems like a good place to start. So I might try and focus on this triangle that's happening in the diagram, where it's 11, this guy is 50, and then this angle measurement is 11.3. We also have this angle on the outside, which is 21.8. Since I'm adding it into this new diagram, you've probably caught on that I need to somehow bring it in. In bringing it in, I can use my linear angles. I'm going to do 180 minus 21.8, and I get 158.2. For that guy. So I have a triangle here that I can solve for any of the pieces that I want. I can solve for that remaining angle, which I'm actually going to have to, and then I can solve for any of the side lengths here. I want to take a second and make a plan of action. If I solve for the longest side length on the top there, that longest side length at the top, I'm going to label it as X, would be that side length right there, which would be super helpful because once I have that, I can focus on the biggest right triangle. A second triangle we can pull out of here. that would be x, and this would still be 11.3. So I'm going to solve for x here, and then once I have x, I can then solve for the height of the building, which is y over here, which is not the full height of the building. Keep in mind that we still have that 1.8 that we have to add on at the end. But I've got a plan. I'm going to first solve for x, and then I'm going to solve for y. Focusing on my first diagram, well, I guess my second diagram, trying to solve for x, I'm going to use my law of sines here because I've got a ton of angles. The more angles I have, law of sines I would use, versus if I had only sides, I would use law of cosines. But since I have angles, I'm going to use law of sines. I need to solve for this missing angle up here so I can do sine of that angle over 50, the only side length I have here. So I'm going to do 180 minus 158.2 minus 11.3, and I get 10.5 degrees. I am going to now do my law of sines. Sine of the angle, which is 10.5, divided by its opposite side, which is 50, equals sine of the other angle, which is 158.2, divided by its opposite side. Cross multiply and divide, I get x times sine of 10.5 equals 50 times sine of 158.2. Dividing both sides by sine of 10.5. And we get that x is equal to 101.9. Again, this is a placeholder. It's not our final answer. So we've rounded it to write it down, but we're going to use our exact values in our calculator. Now I have this guy I've just solved and found that this is 101.9. I have that guy. I want to solve for y. So I have the hypotenuse and I want to solve for the opposite, which is going to be sine of that angle. Sine of, and here we're using SOHCAHTOA, right? So this is a great example to show you how and when and why you would use SOHCAHTOA versus why you would use law of sines or law of cosines, because in the real world, we're not always given right triangles. Sine of 11.3 is equal to opposite over hypotenuse. So y is equal to 101.9 times sine of 11.3. So I'm going to multiply my previous answer by sine of 11.3. And I get that y is equal to 19.97. And then I just have to remember that the height of my building is that guy plus 1.8. So that's going to be 19.97 plus 1.8, which is 21.8 meters. And there you go. That's your answer. Okay. Let me know if you still have any more questions about trigonometry and how to use it and what is being expected of you. I hope that this helps. Please continue to let me know if there's anything I can do to help keep you motivated and on track as we are still moving forward in school. Okay, thank you.